Hello guys, today we will do probability revision for class 10 boards. So let's for it we will follow the same pattern. First we will do concept building. I will just revise all the basic. I will give you a brief summary of all the basic concepts that are needed in probability before you can attempt problems. So it will be quick session. I will be giving you a very brief summary of all the concepts, and then we will do few problems. So I think that will kind of help you in your revision for probability for your upcoming boards ICSE. Okay. So having said that, let's get started. I will just change this color. Just give me 1 second. Okay. So a summary of what concepts you need in this uh, probability. So number one that you need to know is what is a random experiment. So what is a random experiment? So random experiment is such that there will be, like, let's say you perform one experiment, okay, and there are like more than one outcomes, and it is not possible to predict the outcome in advance. Okay, let's say you are, so let me first write this thing. So more than one outcome, that is like 1 point, more than one outcome, and number two is not possible to predict the outcome in advance. So that is a random experiment. So let's say I am giving you an example. Let's say you are tossing a coin. Okay, tossing a coin. So what are the outcomes for tossing a coin? It can be head, right? It can be tail, right? So these two are the possible outcomes. They are like possible outcomes for the random experiment tossing a coin. You see, two outcomes are there, right? And it is not possible to know if it will be head or if it will be tail, right, before you actually toss the coin, right? Then let's say another easy example will be rolling a dice. So when you roll a dice, what are the outcomes that it can come? It can be 1, it can be 2, it can be 3 or 4 or 5 or 6. See, there can be so many outcomes if you roll a dice, right? Like six outcomes specifically. So more than one outcome, and it is not possible to predict when you roll, before you roll a dice, whether it will be one or two or three or four, five, six. You don't know what it will be, right? So these are two examples. Let's say I gave you two examples which are commonly used for random experiment. Okay, so I hope you understood what is a random experiment. It will be more than one outcome, and it is not able, and you are not able to predict the outcome in advance. Okay, so that is called a random experiment. Now, let me just do it here only, it will be easier. Now, we will cover the second topic, second concept that is needed in probability. That is, what is sample space? Sample space is collection of all the outcomes. Collection of all the outcomes of a random experiment. So what do you mean by this? So basically, let's say collection of all the outcomes in a random experiment is sample space. Let's say for the first example, tossing a coin, which I did. What are the outcomes we got? We got it can be head, it can be tail. So the sample space will be for tossing a coin. The sample space will be head and tail. Head comma tail. This is a sample space. These are the two outcomes that are possible for collection of all the outcomes. This word is very important, all the outcomes, just remember this, collection of all the outcomes, that's it, of a random experiments. So let's say there is another experiment which we did. I just gave you the example, rolling a dice. So what is the sample space in this in this random experiment? So it can be either 1 or 2 or 3 or 4 or 5 or 6, right? So basically this set is the sample space for rolling a dice. Okay. Now the third thing that is important to know, let me just mark these things in yellow. This is number 1 point that I discussed right now, number 2 point, and number 3 point. Okay, let me write this also. What is an event? Okay, just 1 second. Okay, so what is an event? So us, let's say, the formal definition first, let me say a subset of the sample space associated with a random experiment. So basically a subset of the sample space. Sample space is the entire set of the random experiment, entire collection of outcomes, right? The entire set is the sample space. So event is a subset of the sample space associated with a random experiment. This is a formal definition, but you need to know that this is a subset of the sample space. So let's say for this example, tossing a coin, one event can be, let's say for the random experiment, tossing a coin. Okay, one event can be, let's say one event is A, which is always head, always head as the outcome. So what will be the what will be the I mean the subset here? It will be H, right? H should be the favorable outcome, right? Let's say, let me go to the another sheet. It will be more clear. Let's say for it will be more clear if I do it here. Let's say roll for this random experiment, rolling a dice. For let's say we are discussing this random experiment, rolling a dice. Okay. So one event can be, so okay. So this is our random experiment. First, let me also write the sample space here. So for this random experiment, the sample space is 1, 2, 3, 4, 5, 6, right? So let's say one event can be uh, all odd numbers. So a subset of the sample space associated with the random experiment is an event. So when it's all odd numbers, what will be the outcomes here? It will be 1, 3, and 5, right? So 1, 3, and 5 is a subset of this total sample space. Actually, I mean the original sample space. So this is an event which is all odd numbers. Either the next another event can be, let's say, event 2. Event 2 can be, let's say, all even numbers. Okay. So what will be the outcomes then? 2, 4, 6. Let's say event 3 can be all prime numbers. So the outcome will be, what are the outcomes here? If it's all prime number, 2, 3, 5. Let's say event 4, giving you a few examples, right? Event 4 can be all numbers less than 5. So here for this case, your set will be, outcome set will be, for this event all numbers less than 5. For the random experiment, rolling a dice, will be 1, 2, 3, comma 4. So I hope this is clear to you guys. You guys have understood right now three important topics which I discussed, which are: number one, I discussed about random experiment; number two, I discussed about what is a sample space; and number three, I discussed about what is an event. So I hope you guys have clearly understood these three things. Okay. So let's move on and let's build some other concepts, okay, in this probability. So it will be, if you understand these treats, it will be very easy after this, okay. uh, at least up till the class 10 syllabus, okay. So so let's now go to the what is the definition of probability, okay. So we will see what do you mean by probability. Before I mean, I two more points I forgot to discuss. Okay, just give me 1 second. Let me erase it before I go to the formal definition of probability. These two, you will encounter these two terms quite a bit. So let me write it down. Some frequently used terms. Okay, you will encounter these two terms quite frequently. Number one is favorable outcomes. So what do you mean by favorable outcomes? I was not using this term before, but now that I'm introducing you this term favorable outcomes, henceforth I will use this term favorable outcomes quite frequently, okay, when it comes to probability. So outcomes which ensures the occurrence of an event are called favorable outcomes of that event, okay. So basically the formal definition is outcomes which ensures the occurrence of an event. So outcomes which ensures the occurrence of an event. What do you mean by that? You see, I gave you so many examples here. When the event is all odd numbers, then what is this? This is a favorable event. For this is a favorable uh, set for this event, all odd numbers 1 3 5. For this event 2, what is the favorable outcomes? Basically this set 2 4 6. For this event 3, what is the favorable outcomes? This set 2 3 5. I was not intentionally, I was not using this term favorable outcomes while describing this kind of sets. The only reason was I didn't introduce this term at that time, okay. So all these are like the favorable outcomes. Like for this event, for all numbers less than 5, what are the favorable outcomes? 1, 2, 3, 4. Okay. So so now I hope you understood. Even whatever we discussed here in event here. For for tossing a coin, always head. What is the favorable outcomes? Only this set H. Okay. So, having said that, we understood what is favorable outcomes. Now we need to understand one more term, which we will see quite many times, which is equally likely outcomes. So, what do you mean by equally likely outcomes? So, let's say we say the outcomes are equally likely when all the outcomes have equal chances of occurring. Okay, when all the outcomes of an event, okay, so I'm just writing here, it can be event or random experiment, whatever, when all the outcomes have equal chances of occurring, we say the outcomes are equally likely. So just want to give you a brief idea what I mean by it, equally likely outcomes. Let's say this sample space, let's start from here. We roll a dice. This is we saying this is a sample space which is 1 2 3 4 5 6. So it can be, when you roll a dice, you don't know before, right, if it is 6 or if it will come out as 3, or you will see a 4, or you will get a 5 or a 2 or a 1, you don't know, right? So that means this is a equally likely outcomes. The outcomes are equally likely. 2 is as likely, you are as likely to see 2 as you are likely to see 5. You don't know, both have the same chances. Similarly, for this event, all odd numbers, it can be 1 or 3 or 5, right? Basically basically for this event, the chances of it is like 1, or if it drops 3 or 5, that is same. Okay, so that is called equally likely outcomes. Okay, so let's say again this tossing a coin, it can be head or tail. This is a sample space, so you have equally likely chances of it can be head or it can be tail. So both the chances are same. Okay, so I hope you understood what is equally likely outcomes and what is favorable outcomes. Okay, now we will move on to one more definition, which is the actual definition of probability. Okay, before that, just give me 1 second. Let me get some more pages here so that I two three blank sheets. Okay, one more just in case. Okay, okay, just 1 second. I think we are good now. Oh, I need to change the color here. Okay, so now let's go with the classical definition of probability. What is a probability? So probability means favorable number of outcomes divided by total number of possible outcomes. Okay, so first let me write this: favorable number of outcomes divided by total number of possible outcomes. So what I mean by this, you see, I just discussed what is a favorable number of outcomes. So if you perform let's say you perform a random experiment, you performed a random experiment. Okay, you performed this. After you performed the random experiment, you got a sample space, right? You got the sample space where all the collection, total number of outcomes are included in the sample space, right? So this sample space will come here, generally in most cases. Right now, yes, for class 10 it's always here. So this sample space will come here, this total number of outcomes for the random experiment. So this is the denominator, and favorable number of outcomes, let's say now you perform an event. Okay, now the event has some subset of sample space, right? Subset of this sample space. So this is the your favorable number of outcomes with respect to this event. So this will come on the numerator. Okay, this is a general rule we will follow. There will be a random experiment and we will get some sample space. We will put it, that will be the total number of outcomes. We will put it in the denominator, and the event, which is the subset, the event will be favorable number of outcomes. We will put it in the numerator. Okay, so I hope you are getting it correct. Let me give you an example, a quick example. Let's say the same examples which I discussed, rolling a dice. So rolling a dice is a random experiment. Okay, so the sample space, what I'm writing. Okay, rolling a dice. So the sample space for this rolling a dice is 1, 2, 3, 4, 5, 6. So this is the total number of events, right? Total number of, very sorry, total number of outcomes, right? Definition of sample space. Total number of outcomes is 1, 2, 3, 4, 5, 6. Okay, now your event is number which is even, number which is even. So what is the favorable number of outcomes for this event, number which is even, which is 2, 4, 6, right? So this set is your favorable set. Favorable set is 2, 4, 6. This is your sample space. Now what will be the probability? Let's say this event is E. So what will be the probability for this event E to happen? You will do P of E, which is a favorable number of outcomes. So how many number of favorable outcomes? 1, for 2 it's 2, 6 is 3. So favorable number we will count 3 divided by how many number of sample space. In the sample space how many number is there? 1 2 3 4 5 6. So 3 by 6, so 1 by 2. So this is the probability of the event happening, that when you roll a dice it can be a even number. Okay, another example, quick example, let's say event A. This is the event, a prime number, a prime number, you will get a prime number. This is the event. So how many, what are the favorable set which is a prime number, which can be, let's say, 2 3 5. This is a favorable set, right? If you are prime number, this is a set you will get. This is the outcomes you can get if for the event a prime number, right? So what is the probability of a, what is the favorable number of outcomes divided by total number of outcomes? So favorable number of outcomes is 1 2 3. Total number of outcomes, again this is the total, your sample space, total number is 6. So 3 by 6 is again half, a prime number is again half. That's the probability of the event a prime number. Okay, so okay, I hope you got what I said up till this point. One more thing I will do it, I will teach you is complementary set, complementary event. So let's say this is your total outcome set. Okay, this is your total outcome set. Now you performed an experiment E. Okay, and the probability of the probability here is of the event E to happen is PE. Okay, but for the universal set, the probability, all the probability of all the events, right? A probability of all the events inside this random experiment, if I add it up, that will be one, right? So always remember this: the total probability is always one. Okay, so if this is probability of E, the rest of the part, that will be probability of E complement. Okay, so whatever except E event, all the other outcomes we put it on this, the under the umbrella P of E bar. That is called the complementary event. Okay, and as I said before, so total probability is always one, right? So this probability of E plus probability of E complement equals 1. So let's say giving you quick example, rolling a dice, the sample space was 1 2 3 4 5 6 for rolling a dice, right? This was a sample space. So for the event, it's an even number. What was the outcomes that we got for the event? Even numbers, even numbers. So the outcome we got as 2 4 6. Okay, now say I want to find complement of this even numbers. That means whatever is not even will come under the set now. That is 3, sorry, 1 3 5. Whatever is not in this set will come into this set, 1 3 5. So probability of even numbers is how much? Favorable number of outcomes by total number of outcomes, and this one is also this 3 by 6. So total we get it as half plus half. The total probability is 1. So total probability will always be 1, right? So just remember this: total probability will always be 1. Okay, and this is a PE plus PE complement is equals 1. So this is complementary event. So what is the number here? Some frequently used terms. Just one second. So okay, three parts we did, three concepts here. Then we learned this concept. Some frequently used terms we learned. Two of them, one is favorable outcomes. Now number two is equally likely outcomes. Then we learned this probability definition 5. Okay, 5 concepts we learned here. What is the definition of probability? 6 we learned is what is complementary event. Okay, now we will do the seventh one, and one more is here. That's it. This is very simple. This is not that difficult. No, I mean it's just you have to know this. This is a knowledge thing. So let's say you have pack of 52 cards. Okay, you have pack of 52 cards. I will just let you know how the cards, because you may not know what the card game is, right? So I will give you a brief on the card game, how what are the type of cards you have, because questions might probably come from cards and they expect you to know at least how what is there inside this pack of 52 cards. So I will just give you that brief. Okay, so this 52 cards, so you have 52 cards. They will be divided into four suits in the set. Okay, in the if you have ever seen a card 52 cards like this, you will see they are divided into four suits. Four suits. Okay, so number one is hearts. You will get a hearts. You will get a spade. You will get a clubs. You will get a diamond. So heart looks like, so this card looks like this. Diamond will look like this. This all the cards under diamond will have this symbol basically. And spade and clubs. Let me show it here with this pen only. Spade will look like this. Okay, and clubs will look like this. Okay, so out of these 52 cards, it's divided into these four types. So, and each type will have a 13 cards, each type. So hearts will have 13 cards. Spade should have 13 cards. Similarly, clubs will have 13 cards, and diamond will have 13 cards. Same cards of same type. So no, not same cards. I'm saying these 13 cards are of the same type, but they one falls under heart, one falls under spade, one falls under clubs, one falls under diamond. So it will be divided into 13 cards. Now let us see what are those 13 cards. You will get one ace, one king, one queen, one jack, and then simple number cards from 2, 3, 4, 5, 6, 7, 8, 9, 10. So you see 4, 5, 6, 7, 8, 9 cards here, and these 4 cards. So 9 plus 4, 13 cards you will get. So 13 cards of hearts. Similarly for spade you will get one ace, one king, one queen, one jack. Similarly, simple number cards from 2, 3, 4, 5 up till 10. So here you will get 9 cards, here you get 4 cards. Same like this, hearts. So 9 plus 4, 13. Similarly for clubs, 13. Similarly for diamond, 13. Okay, but this ace will only of ace of 8. This ace will be ace of hearts. And this ace will be ace of clubs. And one ace for diamond, this ace will be ace of diamond. I hope you are getting this point, right? Let's say this number 3, right? They have a ace, king, queen, jack, then 2, 3, 4, 5, 6, 7, 8, up till 10, right? So let's say this 3, and what is the difference between this 3 and this 3? Because this 3 is a 3 of diamond, whereas this 3 is a 3 of spade. Okay, so this I hope you got it clear. They will ask you problems on a pack of 52 cards or probability problems, and they expect you to know how the cards look, how this set looks. They expect you to know this thing. Okay, and one more thing let's do. There is no sheet. Just 1 second. Let's add two more sheets. One more. I think one is fine. Okay. One is fine, I think. And after that, we will start the problems. Okay, we will see some of the problems how to deal with. Let's say, let's say you are tossing. I'm giving you an example here. Okay, let's say tossing two coins simultaneously. So tossing two coins simultaneously. So what will be the sample space for this random experiment? This is a random experiment tossing two coins simultaneously. So what will be the sample space? Okay. So you see, when you toss the first coin, it can be head, and the second coin you toss, it can be head. The first coin you toss, it can be head. The second coin can be tail. The first coin you toss, it can be tail. The second coin can be head. The first coin you toss, it can be tail. The second coin, when you toss, it can be tail. Right? So this is the sample space that you will get when you toss two coins simultaneously. This is the sample space you will get. All right. Let's say you want to toss three coins simultaneously. So what is the sample space that you will get? First, let's say you can get head. Next, you can get head. Then third can be tail. Let's say you can get head. Let's say this can be tail. This can be head. Let's say you get head, tail, and a tail. Let's say this can be a tail, a head, tail. This can be tail, tail, head. This can be tail, tail, and tail. Right? Another can be tail, head, head. Right? And here we can also get a head, head, head. So basically, you see, these are the number of outcomes you will get when you do toss three coins simultaneously. Right? This will be the sample space. Just giving you this example. So basically, here what is the number of total number of events, total number of outcomes. So here the total number of outcomes will be 4 and 4, 8. Here the total number of outcomes will be 4, right? So one more example is, let's say you toss, sorry, you roll two dice simultaneously. So this is your random experiment. Roll two dice simultaneously. Then what will be the sample space for this rolling two dice simultaneously? Let's say this, you can do it like this way. One, two, three, four, five, six. Okay. You write 1, 2, 3, 4, 5, 6 in the columns, and you write here 1, 2, 3, 4, 5, 6 here as well. Here it will be, let's draw this boxes. Okay. So when you roll two dice simultaneously, what can be the sample spaces? It can be 1, 1, or it can be 1, 2, or 1, 3, or 1, 4, or 1, 5, or 1, 6, or you can get 2, 1, or 2, 2, or 2, 3, or 2, 4, or 2, 5, or 2, 6, right? Similarly, 3, 1, 3, 2, like that it will go up till 3, 6, 4, 1, 4, 2, 4, 3, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6. So how many number of what is the sample space? How many number of outcomes you have in the sample space? This is 6 here and 6 here, right? So the total number of outcomes, or you can call this a sample space for the random experiment that is given, roll two dice simultaneously, will be 6 cross 6, that is 36. Right? So hope you got the ideas clear, right? Oh, you understood what is probability, what is random space, what is sample space, what is an event, and I gave you few examples to demonstrate the concepts, right? And the commonly used terms, favorable outcomes, equally likely outcomes. Okay, and you understood how this pack of 52 cards will look like. Okay, so with that, I think your basics are clear. Now you can move on to the problem solving. So let's solve some problems, and I think with that, your revision for ICSE board's probability will be good. Okay, obviously there is no end. You can do more problems on your own to boost your confidence after the video ends. That is for sure encouraged. But at least this will give you some base. Okay, so let's start the same first problem. Same approach. Please pause the video, try it on your own first, and then see how what the solution is or how we can solve it. Okay, so first try it on your own. That will do a lot of help to you. Okay, so a die is thrown once. A die is thrown once. What is the probability that number is even? So what is a random experiment here that's performed here? Random experiment that is performed here is a die is thrown once. Okay, this is a random experiment that is performed. So what is the sample space here? Let's go from the basics. The sample space here is when a die is thrown once, either it can be 1, 2, 3, 4, 5, or 6. It can be 1, 2, 3, 4, 5, 6. Anything can come out, right? So what is the probability that the number is even? Now they have asked you what is the event given. The first event is number is even. Okay, so what are the favorable outcomes for the event the number is even? So for this event number is even, what are the favorable outcomes for this event? So the favorable outcomes will be number is even. You see, 2 it can come out, 4 it can be, 6 it can be. Okay, so it can be either 2 or 4 or 6, right? So now they have asked you what is the probability for this event number is even. So required probability, what it will be? From the definition of probability, favorable number of outcomes divided by total number of outcomes, right? Right, so what is the favorable number of outcomes here? 2, 4, 6. The number is 3 numbers of favorable number of outcomes. The sample space, how many numbers how many numbers are there in the sample space? 1, 2, 3, 4, 5, 6, right? So 6. So favorable number of outcomes will be 3, total number of outcomes will be 6. This will be half. So hope this is clear to you. So number 2 is, it's given number is greater than 2. Again, favorable outcomes, or you can write set of favorable outcomes. That is better. Whatever. You have to make it sure the examiner understand it. So write something. Just don't do required probability 3 by 6 equals half. You show them this is a random experiment. This is a sample space. So this way your examiner is like good. He understands that you understood the problems. He will give you all the marks. Okay. So set of favorable outcomes for a number is greater than 2. So number of greater than 2, so it can be set of favorable outcomes for the given event. You can just write for the given event, that's fine too. So that will be 3, 4, 5 or 6, right? So required probability, what is the required probability? Similarly, just write the definition, favorable number of outcomes by total number of outcomes, right? Just write it entirely. So favorable number of outcomes for the event number is greater than 2 is this one. How much is a favorable number? How many? 4. So 4 is in the numerator. Denominator we already saw. What is the number of outcomes samples in the sample space is 6. So answer will be 2 divided by 3. So this is answer 1. This is answer 2. So hope this is clear to you. Let's move to the next problem. So I hope you are solving it on your own first. A die has 6 faces marked by given numbers as shown. So these are the 6 numbers that are in the die. The die is thrown once. What is the probability of getting whatever positive integer, an integer greater than minus 3, a smallest integer? So here your sample space is 1, 2, 3, minus 1, minus 2, minus 3. This is your sample space, right? Now for the one, a positive integer. So set of favorable outcomes for the given event, that what is the set of favorable outcomes is a positive integer. It can be 1, 2, and 3. These are the positive integers, right? And the next, these are the negative integers, right? So what are the set of favorable outcomes? It will be 1, 2, or 3. And then what is the probability? Required probability is number of favorable outcomes by total number of outcomes. So that will be, what is the favorable number of outcomes? 3. What is the total number of outcomes? 6. So this will be 3 by 6 equals half. So number 2, are integer greater than minus 3. So the set of favorable outcomes, what is it? Just write entirely. An integer greater than minus 3. So basically an integer which is greater than minus 3 will be minus 2, minus 1, 3, 2, 1. Right? All the other ones except minus 3. So this is your favorable outcome set. So required probability will be num number of favorable outcomes, which is 5 in this case, and total number of outcomes, which is 6. So it will be 5 by 6. Right? Hope you're getting the point, right? Anywhere which you don't understand comfortably, write in the comment section. We will see how to address that concern that you have. And what is the probability of getting the smallest integer? Okay, what is the probability of getting the smallest integer? So for this set of favorable outcomes in this case is only one is there, right? Smallest integer, the set of the favorable outcomes, the event is like only one has to fall. That is what it's asked. So what is the probability of that this die, when you roll this die, one will come out? So the required probability in that case will be favorable number of outcomes divided by total number of outcomes. Here it is 1. So this will be 1. Total number of outcomes we already saw here. This is 6. So we will do 6. So answer is 1 by 6. So this is 3. This is answer to 2. And this is answer to 1. Hope this is clear to you. We will move to the next problem. So here it said cards marked with numbers 1, 2, 3, 4, 5, 6, 7, 8, all the way up to 20 are well shuffled and a card is drawn at random. So there is a set of numbers with from 1 to 20 and one card is drawn at random. So what is the probability that the card number that on the card that you drew, that the drawn card basically is a prime number, is divisible by 3 or a perfect square? And this question came in 2010. Okay. So what will be the sample space? So the sample space, a card is drawn, a card marked with numbers 1 to 20 are well shuffled. This and the card is drawn at random. So your sample space contains 1, 2, 3, 4, all the way up to 20, right? So this is your sample space, right? The random experiment is a card is drawn at random from this numbers 1 to 20. So your sample space will be either 1, 2, 3, 4, 5, 6, all the way up till 20. Now your event is, what is the probability that the event is a prime number? Basically, first question. So set of favorable outcomes for the given event, the card is a prime number. The drawn card is a prime number. More specific. So first, let's see what are the set of favorable outcomes when the drawn card is a prime number. It can be either 2, 3. So what are the prime numbers from 1 to 20? 2, 3. It can be 5, 7, 11, 13, 17, 19. Right? These are the set of prime numbers from 1 to 20. And then the required probability will be similarly favorable number of outcomes divided by total number of outcomes, right? So it will be 1, 2, 3, 4, 5, 6, 7, 8. Favorable number of outcomes is 8. Total number of outcomes is 20. 1 all the way till 20. So it's 20. So basically this will be 2 by 5. Okay. So number 2, it is divisible by 3. So for that favorable outcome set, I'm just writing it like that, right? Everything, okay, set of favorable outcomes for the given event divisible by 3, card is divisible by 3. If you have time, if you don't have time and you're in a rush, then just write favorable outcome set, the set of favorable outcomes, that is fine. Okay, but if you have time, just write it. Okay, but please see time also, time also matters, right? So it's divisible by 3, so it can be either 3. So what are the numbers which are divisible by 3 from 1 to 20? 3, 6, 9, 12, 15, 18. So from here the required probability will be, what is 1, 2, 3, 4, 5, 6. 6 divided by all this 20. 6 by 20, that is 3 by 10. So number 3, a perfect square. Favorable outcome set. What is a favorable outcome set? It can be either 1 or maybe 4 or 9 or 16. 5 square is how much? 25, which is greater than this 20, right? You don't have that option only. So the total cards is from 1 to 20. So there is no 25. So you cannot get 25. Okay. So you can either get it as 1, or you can either get the drawn card as 4 or 9 or 16. This is your options, right? Then the required probability will be favorable number of outcomes, which is 1, 2, 3, 4, by total number of outcomes is 20. This will give you as 1 divided by 5. Hope this is clear to you. Let's move to the next problem. So a bag contains, okay, we have three more problems. So solution. A bag contains 15 balls, of which, let's say this is a bag. 15 balls are there, of which some are white, like that, some are white balls, and others are red. So let's say some other balls are there in the bag, which are red. Now we don't know how many. Okay. So, and we don't know how many white balls are there also. So now they have asked if the probability of drawing a red ball is twice that of a white ball. Find the number of white balls in the bag. They want you to find the number of white balls. Okay. So first let us consider probability of drawing a white ball. be X, let's say. If probability of drawing a white ball is X, what is the probability of drawing a red ball? It is said in the question only. See, the probability of drawing a red ball is twice of that of the white ball. Therefore, probability of drawing a red ball is 2 times X, right? It's given in the question only. The probability of drawing a red ball is twice that of a white ball. So 2 times X, right? Therefore, you can set this problem according to the problem it's given. Okay, yeah. So therefore, according to the problem, the total probability I said, right, 2x plus x has to be 1. So when you pick one ball from here, either it has to be red ball or or a white ball, right? So the total probability will always be 1, right? When you draw one ball from the bag, when you draw a ball from the bag, the total probability has to be 1. So 2x plus x is equals to 1. So basically x is equals to 1 by 3. So that means the probability of drawing a white ball be 1 by 3. So that you got. Probability of drawing a white ball, you got it as 1 by 3. Find the number of white balls in the bag. Again, let's consider, again you can write, let us consider the number of white balls as y. Okay. So again you can just write, you can frame uh, this equation, which is the probability of drawing a white ball equals 1 by 3 equals favorable number of outcomes, which is total number of white balls in the bag, which you considered as y, divided by total number of outcomes. So the total number of balls in the bag were 15. So, right, so from 15, if you the numerator is y, these are the number of white balls, this is the total number of balls. That probability you got it, already got it as 1 by 3, right? From here you can find what is the value of y. Y is 5. So this is your answer. Just write a proper answer at the end. Therefore the number of white balls is 5. Just write a proper answer here. Okay, so let's move to the next problem. So please try this problem first and then we will see the solution. Okay, so from a pack of 52 cards, now this is a card problem. I said they expect you to know how the cards look. So 52 cards, a black jack, a red queen, and two black kings fell down. A card was drained. Okay, so they had 52 cards initially. So now few cards are fell down. Okay, and a card is then drawn from the remaining pack at random. Okay, so basically now how many cards fell down? One, two, and two black kings. So 52 minus 4 cards fell down. Now they have 48 cards. And a card is drawn from the remaining pack, so now they are drawing the card from 48, so you have total 48 cards. Okay, so basically the sample space will have all these cards 48, whatever these cards are right now. So basically all the cards minus a blackjack will be subtracted from the set, a red queen will be subtracted, and two black kings. So two black kings we can understand. This is one is of spade, one is of clubs. The red queen, it can be either from the hearts or from the diamond. That is not said. A blackjack, it can be either from the jack of spades or jack of clubs. Right. So now let's say let's come to the problem. Find the probability that the card drawn is a black card. Okay. So number one, probability that the card drawn is a black card. So favorable number of outcomes divided total number of outcomes, first write it. Then you see how many black cards are there. A black jack, they have taken out a black jack. Okay, red queen they have taken out, and two black kings fell down. So basically three black cards have been taken down first initially. These three black cards fell down, so now you don't have these three black cards. And how many black cards should be? In a 13, 13, 13, 13. This 413 consists of this 52 number of cards, right? Out of that, two sets are black and these two sets are red, right? So from this black set of 13 cards, three cards fell down initially. So these three cards are nowhere in the scope itself. They are out. they are gone. Okay, so basically, how many favorable number of what are the not favorable number of outcomes that a card drawn is a black? So this will be 26 minus 3, right? And what is the total number of outcomes? Now you have how many cards? 48, not 52, right? So for 26 minus 3 divided by 48, so it is 23 divided by 48. Hope this is clear to you. Probability that the card drawn is a king. Probability that the card drawn is a king. What is the probability the card drawn is a king? Divided by its 48 now, right? Total number of outcomes, it is 48. Okay. Now let's see the what will be the numerator. Favorable number of outcomes, a king. So you see two black kings, they already fell down in the beginning. How many kings should be there in a 52 sets? I said one king for each suit, right? So it's like one king for spades, one king for clubs, one king for diamond, one king for hearts. So four kings. Out of four, two black kings fell out. So it should be 4 minus 2, right? So 2 divided by 48, it should be 1 divided by 24. Let's go to the next problem. A red queen. Similarly, probability that the card drawn is a red queen. So a red queen fell down. So let's say you have a red queen for a diamond and a red queen for hearts. So one of them fell down. So one of them is still there in your 48 cards pack, right? One of them is still there. So the favorable number of outcomes will be 2 minus 1. So 1 is there and total number of outcomes is 48. So it's 1 by 48. So these are the three answers. Write a proper answer at the end. Okay. Hope this is clear to you guys. So if you're okay, let's move to the next problem. Try it first, okay, and then we will see the solution. Okay, the same rule applies for all problems. That way, even if you cannot answer the problem, it's fine. When I discuss it, you at least gave it your full try, right? So you will grasp the solution properly. Otherwise, you will not give it that importance. Your brain will not work well if you just see the solution passively, right? Be active participant in all every time. Whenever you find a problem, it's just not for mathematics. Whenever you find a problem in life, try to give it your shot first, and then okay, then you seek help. So let's do this solution for this. Two different coins are tossed simultaneously. Find the probability of getting two tails, one tail, no tail, at most one tail. Okay. So when two different coins are tossed, I discussed it. What will be the sample space? I discussed it before. When two coins will be tossed, it can be either head, tail, or head, head, or tail, head, or tail, tail. This can be the sample space, right? Find the probability of getting two tails. So required probability, just write it properly. The probability of getting two tails for the event two tails equal to favorable number of outcomes divided by total number of outcomes equals to the set can be or you can just or and then top you write it's the favorable number of favorable set for this event two tails. What are the favorable set? Let me just write that also before. Just 1 second. I will just erase this. Just at least for one, let me show you this in case you haven't understood it before. At least let me give you one more try so that you understand it now. So find the probability of getting two tails. So what is the favorable outcome set? Favorable outcome set. Find the probability two tails. Okay, so it should be tail tail, right? Favorable, this is a favorable outcome set for the event two tails basically. And then what is the required probability? favorable number of outcomes divided by total number of outcomes, right? So favorable number of outcomes in this case here it is 1 and total number of outcomes is 4, right? So this will be 1 times 1 divided by 1 over 4 basically. So number 2, this is 1, done. So one tail is there. Now it's two tail. What would be the favorable outcome set when it's one tail? It can be head tail, it can be tail head. This will be the favorable number of outcomes. So what would be the required probability in that case? Favorable number of outcomes. How much? 2. And total number of outcomes, how many? 4. So it will be half. Hope this is clear to you guys, right? For number 3, what is the favorable outcome set? No tail. So it can be either only head head. That's the only solution. The other ones are head tail, tail head, tail tail. At least one tail is there, right? So then the required probability will be in this problem. Favorable number of outcomes is 1. Total number of outcomes is 4. Answer is 1 by 4. That's it. And the last problem is 4, which is at most one tail. What is the outcome set? At most one tail. It can be tail head. It can be head tail. It can be tail tail. Right, both two tails is also contains at least one tail, right? So two tails also contains at least one tail. I hope this is clear to you, right? So what will be the required probability in this case? Favorable outcomes is how many? 1 2 3 3. What is our total number of outcomes? How many? Sample space 4, so 3 by 4. So that was it for today. So I think we revised all the basic concepts that are there in your ICC syllabus, class 10 syllabus basically for probability, and we discussed the type of problems, all the different type of problems covering all the concepts. Hope this is beneficial to you. If you find it beneficial, please subscribe to our channel and please like and share our videos. That will help us also grow a math friendly community. It will help you as well. You will know when we are releasing new videos. Okay, so we have the plans to cover all the 10 syllabus, 11 syllabus, 12 syllabus, okay, and all the competitive exams which are majorly taken by people after class 12. Okay, so basically, so yeah, that's it for today. Hope you guys enjoyed the video. Thank you. Have a great rest of the day. Bye.